In this video, we are going to write piecewise functions for these two graphs. All right, even though this is an absolute value function, we can also see it as a piecewise function. So we're going to write a piecewise equation similar to the way we will do number 8. To help us see the piecewise nature of this function, I'm going to color the left side blue. Okay, I'm not drawing straight lines today. Let me give this one more shot. All right, I'm going to color the left side blue and the right side red. All right, I secretly think of this as pink, but all my students yell at me and they say, no, it's red. But I think it's pink. Okay. So if I'm going to create a piecewise function for this, it's going to look something like this. So I've got f of x equals, going to have this giant brace. So I'm going to need an equation for the blue side and an equation for the red side. So for the blue side, this is a line, and so I'm thinking, you know, y equals mx plus b, right? So I need the slope and I need the y-intercept. So as I'm looking to see where this graph crosses the grid lines evenly, I'm coming up with these 3 dots. Now, as I do my rise and my run from left to right, it's down 1, right 3, down 1, right 3. So this is negative 1 over 3. That's my slope. So as I do my y equals mx plus b, I have negative 1/3 x, and now I need my y-intercept. Now this blue color stops right here, but the line that contains this goes on forever. So I could continue the line by going down 1, right 3 some more. Okay, now where does this cross over the y-axis? Well, it's right here at negative 3. So that's why I will have negative 1/3 x minus 3. Now if I just left it like that, that would represent the entire line that goes forever. So I need to use a domain restriction to limit just to this blue part. Okay, so I want to stick with x values that are less than something. But see how they're going to the left? So whatever number I say, it's going to be less than that number. It's all about the axis of symmetry, the vertical line that splits this in half. That's the axis of symmetry. And this is x equals negative 3. So that's why I'm going to put x is less than negative 3, because we want the values that go to the left. Now for the red side, well, if this is negative 1/3, then this is going to be positive 1/3. But look at it. If we could put some dots on there if you want. But you see it's going up 1 over 3, up 1 over 3. That's positive 1/3. Now the y-intercept is easy. It's just right there. All right, it's at negative 1. And here we're going to say if x is greater than negative 3 because of the way it's going to the right. Now one of these needs to be or equal to, otherwise we'd have an open circle here. It doesn't matter which one you pick, so I'm going to let it be that one. So that is my piecewise function for this graph. Now let's do domain and range. It goes left and right forever, so that's negative infinity to positive infinity. The range is y values from bottom to top. The lowest value is at negative 2, and then it goes up forever. So negative 2 to infinity is the range. So that's it for problem number 7. Let's slide over and talk about problem number 8. Okay, so we're going to follow the same idea. So we will have f of x equals, and let's do a brace. So we need an equation for this piece on the left. All right, so let's come up with an equation for the piece that I just turned blue. I need y equals mx plus b again. I need the slope and the y-intercept. Now, as I look at some dots that I see on here, it's going up 1, right 1, up 1, right 1. So that's just a slope of 1. So I'm just going to put x. Now I need the y-intercept. If I kept going up 1, right 1, it would look like this. And you can see that the y-intercept would be right there at 7. So I will have x plus 7. If, now this piece is going to the left. Now this number right here, where the lines split, all right, this x value of -2, where it changes from the blue piece over to the red piece. This is not called the axis of symmetry. All right, they are not symmetric the way an absolute value function is. But still, this is the number we use for our restrictions, our domain restriction, because this is the x value where it stops being the blue function and starts being the red function. So the blue function is going to the left. So I'm going to say if, hold on, I want this to be blue. I'm going to say if x is less than -2. Now, will I put or equal to on this? No. When I was doing the absolute value function, I said, oh, it doesn't matter whether which one is the or equal to one and which one is left plain. On this one, it does matter because we specifically have an open circle and a closed circle. All right, the open circle means that this point is not included. -2 is not included. So you will not put or equal to on here. When we do the red function, we will because it's a closed circle here. But first we need an equation for the red function. Let me put some additional dots on here. All right, this is where it seems to be hitting the y-axis. As I continue from left to right, I see it's going down to right 1, down to right 1. So that's -2 over 1, which is just -2. So I'll put -2x. Now the y-intercept, you can see, is right here. It's where it crosses the y-axis. So 2x minus 1. If x is, now this graph is to the right of -2. So these x values are greater than or equal to -2. Again, or equal to, because I see the closed circle, the point at -2 is included. And finally, the domain and range. This graph goes left forever and right forever. So that's -infinity to +infinity. Now the range, the y values from bottom to top. This graph goes down forever. So that's -infinity. But the high point is here at 5. And yes, I see that 5 is an open circle and is not to be included. But don't go to 4, because that would leave out all the decimals in between 4 and 5 that are there. Instead, just use a round parenthesis to show that the 5 is not included in the interval. And that is it for number 8. Okay, this was the final answer. All right, let's keep going. Number 9, they're asking us some details. Okay, we want the y-intercept of the number 7 graph. All right, so don't look at these. We're not going to have 2 y-intercepts. Only one of these is the point where the v touches the y-axis. And it is this point, all right, that I just colored yellow. That's the only y-intercept, so -1. Now, technically the y-intercept is an ordered pair, so I should say 0, comma, -1. Now, the x-intercepts are the places where the graph touches the x-axis. So the graph touches the x-axis in 2 places. So I see -9 and 3. So I'm going to put -9, comma, 0 and 3, comma, 0. Axis of symmetry is this x equals -3 that splits it down the middle. All right, the domain and range, we already did that. The range was -2 to infinity, and then the domain all right, so the domain was -infinity to +infinity, and the range was -2 to infinity. Now we're supposed to write an absolute value equation for this. Okay, an absolute value equation. Remember, the parent function looks like this. Y equals absolute value of x. Whoa. I said absolute value of x, which has a vertex at 0, comma, 0, the origin. Now, compared to that, this graph is left 3 and down 2. So because it is left 3, I need an x plus 3 inside the function. Left-right motion is always the opposite of the way it looks. So x plus 3 would give you left 3. Now, because it's also down 2, I will just put a -2 on the end. Now, sometimes we need a number here in the front. It depends on the slope of the right-hand side. Now, the right-hand side is going up 1, right 3. So that is 1 over 3. And this is positive. It's going up and to the right. Because it's uphill, I know it's going to be positive, so I just leave it like that. So that's the answer. I'll just see if I can recopy it without going off the screen. All right, so here I go. Y equals 1/3 absolute value of x plus 3 minus 2. All right. Now, we're going to use problem number 8 to evaluate. Keep the -6 in mind. And remember that these are each x values. So I'm going to go to an x value of -6. All right, just let me clean this up a little bit. All right, so here is an x value of -6. At this x value, the function is here. So the value is 1, all right, because that's the height of this point. So that's why this equals 1. Now, what about an x value of -2? All right, here's an x value of -2. Now, when I look up, I see 2 different spots. All right, one is at 3 and one is at 5. So do I put them both? No. The open circle means that this point is not included. So this point is the only point that exists at an x value of -2. Now, what's the value of this point? Well, it's the y value, 3. So that's why the answer to that one is 3. What about an x value of +2? All right, here is +2. And I look and see the function is below. It's going to be here. So the answer will be -5. All right? And finally, we're going to evaluate these piecewise functions. So pay attention to the letters. So number 11, it mentions p. So that means we're going to use this function over here on the right-hand side. Now the 0, we are going to look at these domain restrictions, and since x is 0, we'll decide whether we will use the top piece, the middle piece, or the bottom piece. So let's see, is 0 between -8 and -4? No. Is 0 between -4 and 2? Yes, 0 is between there. So that means we're going to use the middle piece. So when it's just a constant like that, then that's the answer. Now on the next problem, it's function j. So focus your eyes over here now. So -2. Is -2 less than or equal to -4? No. Is -2 greater than -4? Yes. -2 is greater than -4. So we're going to use the bottom function. So we're going to be using -x plus 1. Now when I see a -x, I actually think in my mind the opposite of x. So x is -2. What's the opposite of x? +2. So I really have +2 plus 1, which is 3. Okay, the next function also involves function j. See the j? -12. Is -12 less than or equal to -4? Yes, -12 is far less. So that means we're going to be using this function, the 1/4 x minus 8. So this will become 1/4 times -12 minus 8. This really just means divide by 4. So this will be -3 minus 8, which is -11. Now the last problem, we're back to function p again. So I see the 2. And notice I see 2 mentioned here and here. So which one am I going to use? The middle piece or the bottom piece? I'm going to use the bottom piece this time. All right, because the question is, all right, this says 2 is less than or equal to x. Well, 2 equals 2. So that's why we're using the bottom function. And because it's just a constant, the answer will automatically be 9. That's going to be it for this video. I hope it was helpful, and I will see you on the next video.